Okay, in this demo I want to demonstrate to you how to fetch data from an existing web server, so existing web API with an iOS app in Swift, and process the response, which more than likely these days will be some type of JSON document, and then from there get that data up in front of you on a table view. And along the way I'll demonstrate a few additional kind of bonus concepts. So part of my solution will use some Objective-C code that I've stolen from somebody else's GitHub portal or project, and that's Objective-C code, so I'll show you how to go in both directions, how we can call Objective-C code from our Swift code. And we'll also look at the other way. We're going to have that we're going to modify that Objective-C code a little bit so it calls some Swift code that we wrote. So that'll help you when you do your projects, as you might run into this problem. The other thing we'll look at tonight, kind of related to fetching data on the network, is web views and how to work with WebView Delegate, how to get web content on the internet framed within a view that our application is controlling. And you'll remember in the project description, one of the requirements can be satisfied by doing this type of thing. And you'll get some practice in your homework, both fetching a RESTful web service as well as getting some content up into a web view. So I wrote this app in advance, and I'm going to recode it up live for you and talk about what I'm doing as I go. But I thought a good way to demonstrate or get you motivated to pay attention is to actually run the application and demo it to you and then look at the implementation of it. So let me see if I can pull that up. So this is the app, and we'll write the code, but let me just run it for you and explain what it is. Alright, so one of the websites I use, it's kind of probably a bit dated these days, but Last.fm. So this is a music social network where you can put a plug-in on your computer or your phone, and when you listen to your favorite tunes, it takes the metadata off your MP3s and it sends it up to this web service, and then the website is all around creating social graphs around your music preferences. So as you listen to more and more music, it'll find you your music network neighborhood, and you can find and friend other people online that listen to music that is really similar to your own. So it gets to know your personal library, and it does some type of machine learning to figure out, hey, these people are really close to you. You got a lot of compatibility in terms of your personal library. And it's pretty interesting, especially if you like music that's a little bit off the beaten track, or it's not like kind of what everybody listens to, but if you're kind of out in the long tails like I am, you don't meet every day people that like the same kind of music you do. So when you do, it's kind of exciting, and you actually can get to know people online. Like there's probably somebody, well, there are people like in Eastern Europe that have almost the identical classical music library I have, which I just find that kind of interesting. And I've even found local people in West Michigan that have almost the same library I have, and we found out we go to all the same classical music performances and all that kind of stuff too. So it's kind of a neat website, and they have a big open API, and one of the reasons I like to use it in my mobile apps classes, the API is public and it's very simple. So once you set up a dev token for it, you don't need to worry about OAuth authentication or anything like that. It just uses a dev token, and so it just simplifies for instructional purposes what we're trying to get across to you. Some of the APIs you might use in your projects might get a little bit more involved in terms of how you authenticate and do those types of things, but in the confines of the classroom, this is a nice platform to kind of do some experimental stuff on. So here's the app. One of the things they can do is, since they know where you are and how much and what you're listening to, and they got this aggregate data of the whole world using their web thing, they can kind of tell you what is the top tracks, what are the top 50 pieces of music people are listening to in the last 7 days. And so there's APIs that give you this kind of stuff. And so I wrote an app that simply brings up the top, I forget how many the default number is here, but these are the all-time, I think it goes over a week. So these are on the site overall, this is what most people listen to. And so I do a fetch on that API, and it gives me back all the metadata, and then I use that and I populate in a table. And I went a little bit further. I created a detail page. So if you click on the detail page, I pull up a bigger version of the thumbnail for the album. And I also got some buttons down here, artist and track. And if you click those buttons, I actually segue to another view, and I pull up the mobile formatted web content for this particular artist. And if I go back and click on the track, then it will show me the track metadata, or the page for that track, formatted for the mobile device. And what else? Oh, there's some other features here, like I can pop it open in Safari if I wanted to bookmark it. There's an interesting feature if I go, let me go to the artist here, and if I were to click on links, notice my detail button up in the top left corner. If I click on a link, I kind of take over that button and I change it, because now I'm stacked. I loaded another page, and so I turn that kind of nav controller back button into a web back button. And if I clicked one more click, okay, now I'm too deep, and so I kind of intelligently, now if I back up, I go to the previous web page, and if I back up once again, I go to the original page and I turn it back to the back button. So I kind of continue on with that back, and I'll show you how to do that as well. So yeah, that's pretty much the app, and let's go ahead and build this. And maybe before I do that, let me also go to the Last.fm website, and so here's Last.fm, and let's see if I can remember my password. It remembered for me. Come on in. Alright, so here I am, and all my info, my music, and my profile. Okay, and it will also show you, here's my neighbors. These are people that listen to music very similar to my own tastes. So it kind of finds these people for you and shows you some data about their own library. So that's that. And if we scroll down to the bottom here, we'll find Developer API, and that's what we want to look at. So here's the developer, and these are all the APIs that are in here. And I'm using these chart APIs here, so I'm using top tracks. So if I click on this, it'll give me some info about this API. First of all, it'll tell me here's my URL for doing a JSON fetch, and it will tell me, it'll give me the format. So if I click this, I can actually, and it uses my app token, so this is what it's going to look like. And that's kind of hard to read, obviously. So the little thing you want to do here is do a select all on that content. And I use a JSON formatter. So I go here and I select it. And it will tell you if it's valid, and it is, and it'll give you a nice structured view of this. So you'll want to do that in order to figure out how to parse this stuff, right? So you want to get it in a nice structured format so you can figure out how to parse it. But that is the track data. Now, in order to use these APIs, you got to create an API account. All right, and so there's mine. I've got 3 of them, and you simply click this Add API Account info and give it some metadata, a description, and then they will basically give you that token. All right, that's all there is to it. And once you got that token, you'll be able to go in and call these APIs. So each of you will have to do that. I'll get rid of my token before I give you my code so you don't get me in trouble. So that's the back-end system that we're going to use, and you've just seen the web app. So let's go ahead and start the coding. I'm going to start this by creating a brand new project, and I'm going to use the master detail application style app because that's indeed what it is, and I'll call it Top Tracks Demo, and we'll go over to where I've been storing my code, and this is lecture 7. So we'll put that in there. And there we go. So we've done this a number of times. You guys all know what that looks like. We're going to first go in and doctor up this code a little bit. There's a bunch of stuff we don't really need to have here. So I'm going to get rid of some of the functionality that we've had before. For example, I'm not going to insert new objects. And I don't need an edit button, so I'm going to get rid of that stuff. And then I don't need this either then, that method that did the insert. I will need this, but I'm going to have to change the code, so I'm just going to comment that off for now. I'll rewrite these in a moment. And I also don't need any of these guys. So I'm just going to get rid of those two. Those are editing related, and we looked at that code in the past. I don't need any of that, so I'll get rid of that. The first thing I really need to do here is I need to add some code to do that initial JSON fetch against the web API. And so I will go ahead and do that. The first thing I probably should do is go ahead and get me that URL that I'm going to fetch. So I'll go back to this page here, and I'll call this, because that's really the URL I want. And I'm just going to paste this into my code. And in view did load, I'm going to do a fetch. So let me just paste it here so I have it. And the other thing I want to do is change the country from Spain to the United States. So I'm going to get rid of Spain here, and I think I can just say United plus States, the plus for that. And let me just check that. Yes, so that worked fine. So that's what I want to fetch. And so there's a few things we're going to do here. So we're going to use the foundation classes functionality in order to create URL sessions and fetch content. So the first thing I need to do is kind of turn this thing into an URL that iOS understands. So I'm going to say let my URL equal, and we'll say NS URL is the name of the class, and the method or the string parameter is simply the string representation that I'm interested in. And then I close parent that, and that should give me my URL. And then I need to create a session, and we'll talk more about what this stuff means next time. So right now I want to give you the sample code, and I think it's fairly intuitive what we're doing here, and we'll talk in more detail about what it does and some of the options next week. But this will get you started and get you the info that you need. So we're going to say let our session equal to a NS URL session, and we can pass no, we're just going to call the shared session on that one. And then once we have a session, we can now create what we call a download task. And one of the parameters the download task wants is an error object. So the first thing I'm going to do is create that error object, and this is going to be something that's mutable. So I'm going to call this my parse error, and it's of type NS error, and I'm going to have it wrapped in an optional. So I'm going to send a reference of that in, and that's, if I get an error, that's what's going to tell me more information about that error. So at this point I can create my task, and one of the things we need to realize when we do a network fetch is that this is going to take time, right? It's I/O. It's going to go off over the internet. It's going to issue a HTTP request over a TCP connection, so there's setup time for that. It could take milliseconds, more likely even seconds if we're out on a wide area wireless network. And so it's going to take time. And one of the things we don't want to do is, when we're in any of these framework methods, the way the threading model works on iOS is all of the UI is handled by a single thread that is known as the main thread. And this is very similar to most GUI architectures today. And we do that to avoid any type of race conditions. If you have multiple threads updating the UI at the same time, you can get some weird stuff happening. And so the architecture works in that a single thread always updates and operates on the view hierarchy, and that's this thread called the main thread. Now when we're called and view did load, we're called by the main thread, that UI thread. But if I do the fetch on this main thread and it takes seconds, if the user's trying to interact with the app while that's happening, they're not going to be able to, because our app is going to be essentially froze. We've tied up the main thread on this blocking I/O call. So what we do is we do this asynchronously. We actually do the fetch, and when the fetch completes, we're going to give it a closure. Right? We're going to use a closure expression. And when the fetch completes, it's going to run on a background thread. And when it completes, it's going to call our closure. And one of the things we might want to do inside that closure is update the UI. And if we do, then we're going to dispatch that update back to the main thread. Okay, so we're going to give this thing a closure expression, and it's going to do some work. It's going to parse the result we get back when it's done. And then if it needs to update the UI, it's going to put that code also as a closure expression. It's going to send it back to the main thread. Okay, so the main thread will actually execute it. Anything we do on the main thread, we want to happen very, very quickly. We don't want to hold up that thread. So logically, that's what we're going to do. So we do this with a download task. So we can say let task equals, and we'll ask our session object for a download task with URL. And we're also going to give this thing a completion handler. Okay, so we're going to use this one in the very last, since we're going to use the syntax where we pass the closure outside of the parents because it's the last argument. Remember we talked about that as one of the syntactical optimizations. So we can say the URL here is going to be our URL, and we're going to unwrap it because that URL is actually going to give us a optional. And then we can go ahead and put our completion handler in curlies right after this guy. And so we're going to have several things here. So I'm just going to rewrite this guy. So there's my beginning of my closure expression, and the parameters of this expression are going to be the URL that I actually used, or the location here. So this is going to be NSURL. There's going to be a response, which is an NSURL response. And there's an error object So there's my parameter list. And then I'll put the keyword in. And then I should be able to close this. So there's my basic syntax for that closure expression. Now I need to put one or more lines of code inside the closure itself. So what I'm saying here is download this URL asynchronously in the background, and when you're done, call this code with these parameters. So the first thing we do is we get the data out. So we'll say let d equals, and then we can create an ns data by simply calling this ns data contents of file using that parameter. So this gets us the actual data. And now, once I have that data, oops, it's contents of URL, sorry. This is the one I wanted. Once we have that data, we can start to parse it. And we'll do this very similar to what you did back in homework 3. So we'll say let our parsed object, which is of type any object, and we'll let this equal to ns.json serialization .json object with data, and the data here is D, and the reading options will be ns JSON reading options dot allow fragments, and what that says is it'll allow the objects returned to be something other than NS dictionary and NS array if we need it. And then I use this at parseIr. So I'm passing in a reference to my parseIr. So there's my first level, and if we look at so now, if we did everything right, the data that comes back to us is going to be in the form of this, which I think we've already, well, it's right here. This is one I did earlier today. So the data is going to come back where it's a NS dictionary at the top level, and contained within that is another NS dictionary with attribute top tracks, and then there's an NS array within that dictionary with name track. And that track then is an array of all the tracks, each one of those in turn being an NS dictionary. Okay, so that's the structure here that we need to parse. So to parse that, we're going to go as follows. We're going to say if, and so I'm going to kind of check these because when we parse, we're always getting optionals back. So if something went wrong in the API and it wasn't exactly the way I wanted, I'm actually going to kind of defensively do that here, at least to a certain extent. So I'll say if let my top level object, and I'll take that parsed object and I'll cast it because it's an any object, right? And I'm going to cast that thing into a dictionary because I know that's what it should be. And this is a conditional. So if indeed it was a dictionary, then I can open it up, and I'm going to do that by asking it for that top level, that dictionary within the dictionary, which was on the attribute top track. So I'm going to have another statement. I'm going to say if let top tracks equals top level object for key, and then the key name there was top tracks. And I need to cast this guy also as an NS dictionary because we had NS dictionary within an NS dictionary. Now at this point, this particular dictionary, top tracks here, should contain an array called track that has the 50 or so track information in it. So I have one more condition. I'll say if let tracks equals top tracks object for key, and the key here is track, and this time it's actually an NS array. Now I already have an object up here as a model that was generated in the scaffolding, and I'm just going to keep using that same thing as my model. But that's a Swift array, so I'm just going to iterate through this NS array and add each element into my Swift array. So I can do that with a for loop. I can just say for t in tracks, and I can just say self.objects append the track. So at this point, once I've done that, my model is now loaded. Each one of those items in that array is a NS dictionary with the attributes of that particular track. So one of the things I really need to do here, remember this is going to take seconds to complete. It's going off to the internet, so there's a bunch of delay there. Once it gets the JSON back, then I got to walk through it and parse it. There's going to be some delay there, less, but some. And when it's all done, what do I need to do? Now it's time to make sure the screen gets updated, right? So I need to do something to my UI. Right now I'm just loading data into the model, so I need to somehow signal that, hey, you got your data, now you need to load or refresh your UI. And the way, and there's two things to note here. First of all, I've got to do this on the main thread. I can't do this on the thread that's calling this closure because I don't know what that is. In fact, it is not the main thread. All right, and it will not display. So you'll load the data and it won't show up. So if you have this type of a situation where you load data, you debug the parsing code, you know it's getting data, but nothing shows up on the screen, then you got to remember, well, don't expect it to show up if you're doing all this updating from a background thread. It's just not going to happen. So we need to dispatch some logic to tell this thing to refresh or reload its table view. And so the code to reload, let me just type that and then we'll dispatch it properly. So all we need to do is self.tableView. So every UI table view has a view property, table view, that has the actual reference to the UI table view that it's containing and managing. So that's that one, and there's a method on here called reload data. And when you call that, it will simply go back and call all the APIs to repopulate the cells that are currently on the screen. Now if I leave it like this, it's not going to work because that call is happening on the same thread that's calling my closure, which is some background thread. It's not the thread, it's not the main thread. So to get this to go to the main thread, I'm going to simply say dispatch, and it's going to be an asynchronous dispatch, and the queue is dispatch underscore get main queue. Okay, so then I can put a code block after that. So this says take this piece of logic and dispatch it or send it off to the main thread, so when it finally executes, it's going to execute on the main thread. So at this point, my table view would be reloaded, and if I had it completely implemented, we'd actually see this data. Now I don't have it implemented because remember, we got to implement these data source APIs. Okay, right now they're just kind of stubbed out. Well, these two are good, those will work, but this one's obviously not right because it's still using that scaffolding code. So let's go ahead and fix that, that one method. And everything's really okay here. So this line of code is fine. We can use that as is. This one here is not correct because we know that the object here is not a date. That's what the scaffolding code was working with. We're not doing dates though. We're actually doing NS dictionary. So we need to change this to dictionary. So that's now a dictionary. And then we need to change this. It's no longer object.description. And maybe we should make this a little bit more clear. We'll call this a track because that's what it is. It's going to be a track object, which is an NS dictionary. And then we can say get track. And we're going to say object for key. And then what key do we want? Well, let's switch back to our browser here and look at what one of these guys has. There's a name of the track here, and it's just string, and that's what we want. So if we get the ith one, we just need to get this piece of text. So we need to ask it for its name. So the attribute name here is name, and then remember this thing returns an any object, or optional wrapping in any object, and we need to cast that to a string. Okay, and this cell, we're just using a basic plain default cell, and it has this label defined on it. So if I did everything right, when I run this, instead of seeing a list of dates, I should see a list of track names. So let me go ahead and run it. Oh, okay. Small detail. So when you create the task, it's like creating a thread in Java. It just creates the thing, but it's still in a quiescent mode. It's not running. To actually get the task to run and kick off this background thread, we need to call resume on it. All right, so that's like saying thread.start in Java. So now if I run, okay, indeed, now we're going to end up here and there we go. All right, so that gets us that far. Let's add some more data though. One of the things we'd like to do here is show the title of the track and then in small letters underneath it the actual artist. So to do that, we need to make sure we're using the right style cell. So if I go back to my storyboard and I select the prototype, so right here it's using a basic style. If we switch that over to subtitle, that's the style where we get the name in a big font and then underneath it a detail in small font. So if I turn that on, then I can go back into my code here and I can get this thing to show both pieces of information on each cell. So if I go down to here, so this handles the track name, and we want to do the same thing with the artist name. So we can say let the artist equal to, and we'll ask the track object for key, and artist will ask for, and if we look at the code here, the JSON, you'll see that artist is itself an NS dictionary because artists have multiple things. They've got a name, they've got a unique ID, and then there's a profile page for that artist on the website. So we want to pull out that artist's name so it's in an NS dictionary. So in our code, we're going to want to cast this thing as an NS dictionary. So there's our artist, and then we want to set the detail. So this the prefabricated name for this is detail text label, and we need to put the explicit unwrap. And this here is going to be artist, and we'll do a conditional unwrap object for key, and the key name on that dictionary is name, and this thing is a string. And that should be all I do. And if I run that, okay, now I got the name and the artist name on there. But we can go one step further. If we look at the metadata, we'll notice that on this track, we have this attribute image, and we get an array back of arrays. We see the 0th item is tagged as size small, medium, large, extra large. So we can actually get the album cover for that particular track. So what I'd like to do is over on the left put the album cover, then have the title and the subtitle, right? And I want to use this exact same cell. So it turns out that this style cell does have a thumbnail image on it that we can leverage, but notice in the JSON we're only getting the URL to the image. So we need to do another HTTP fetch to bring that URL down. Now, if we start doing this, one of the things you might have noticed here is that there's some repetition here. Like for example, in the first three, here's a hot chip, there's another hot chip. It's very likely we're going to have some common images across these. Same thing would be true if you were pulling down, for example, a tweet stream. If there's people chattering, there's going to be entries from multiple users in that stream. We got the same thing here. And one of the things we really don't want to do is multiple fetches of the same resource. That would kind of burn up battery. There's no good reason to do that. It's just extra bandwidth. We're using up the user's quota, we're draining their battery. So if the image, once the image is downloaded, it would be nice if we just cache it, and in the future when we see that URL, we get it locally from Flash rather than re-download the thing. So I want to fetch those images, but I'd like to do so in using a cache. And there's ways we can actually do this internally using iOS APIs, and you'll find out if you go research it, there is a whole ton of third-party libraries for trying to simplify fetching from web services. And so I'm using the foundation classes here to do this, but the caching piece, I'm just going to grab some code that somebody else has written. So this was stuff I found out on GitHub, and I'm going to incorporate that caching solution because it's really simple and I like how they do it. They use an Objective-C construct known as a category. And a category, we don't have this in Java and maybe some of the other OO languages you're looking for, but it's kind of what we call a mix-in. That was kind of the terminology people used to use for this. But the idea of a category is you want to extend an existing class. So you want to add some methods to an existing class. So everything in the existing class is still the same, its type is the same, you're just adding some new code to it. Okay, and so that's a category in Objective-C. There is a similar construct in Swift. So what I have found was a class out there that extends the built-in UIImageView class, and it gives the capability for UIImageView to get its image data off a URL. And so I can simply take a UIImageView, which is the type of control I've got out there in my view, and I can tell it, hey, go off and fetch this thing, and it actually incorporates a caching solution behind the scenes. Okay, so up at my top level code, I'm simply going to reference this UIImageView load from URL, and everything's going to happen magically. It's going to fetch that thing, it's going to store it in a cache, and it's going to update my view once it's got it fetched. All right? So I'm going to drag this stuff into my project here, and then we'll talk very briefly about what it does. I won't spend a lot of time on it though because it's Objective-C. It's not written in Swift. Okay, so somebody wrote this a long time ago, and it's Objective-C code. But and the reason I want to do this too is that it not only is it easy to use, but it gives me a nice excuse to kind of demonstrate how we bridge and mix different types of modules from Objective-C or Swift within a single project. So right now what we're going to do is add some Objective-C code to our project, and then we're going to call that code from Swift. So to start with, I'm going to go ahead and grab a single class implement. This is a category implementation. It's called UIImageView plus network, and that's the convention in Objective-C when you're doing a category and you're adding functionality to an existing class. The name of it will be the class name plus, and then whatever you want to give it the category name. In this case, it's networking. We're going to add some networking capability to that view. And in Objective-C, just like in C++, there's two files for every class. There's what we call a header, or a .h, which defines the interface of the class, and then there's a .m, which is the implementation file that implements all those methods. Okay, so if you've done any C++, you'll know you do the same thing there. To define a class, you got a .h that defines the class interface, and then there's a .cc or whatever that implements the actual class. So I'm going to grab that one, and then my other class is called ftwcache.h. That's my header, and then the implementation. And then I'm also going to have a placeholder image, because some of these tracks don't have image data uploaded for them. And so in that case, I want to just show a generic Last.fm icon. All right, so I'm going to take all 5 of these files, and I'm going to add them to my Swift project here. And when I drag those in here, one of the things you'll notice is it says, hey, do you want to make copies of these into your local project space? And I do, so I'm going to check that. That will make a copy of it and put it right in there. When you're doing stuff like this, it's really good idea to do the copy, because if you don't do that, when you zip up your homework and send it to me, your project is referencing stuff off on your hard disk that won't get caught in the zip. Right? So make sure if you want to create a self-contained project that you can pack up and mail around or put into Git and so forth. If you're doing that kind of stuff, you'll want to make a copy here so it's self-contained. And we're going to make sure they get copied in. And then Swift or Xcode pops up this thing, and it knows we're doing a Swift project, and it says these are Objective-C code. So it, open these files up and it realizes, hey, this is Objective-C, it's not Swift. Would you like to create a mixed Swift and Objective-C target and have Xcode automatically configuring a bridging header to enable classes to be accessed by both? So it's basically saying, hey, it looks like you're mixing some Objective-C with your Swift. You want us to make this easy so you can get this job done without much work? And we're going to always say, yeah, we want you to do that. And what it does is it goes down here and it creates what's called a bridging header. So this file just got added to the project. And what I can do is in this file, I can do an Objective-C import of any Objective-C code that I want to make visible over on the Swift side of the house. So in Objective-C, our import statements are a little bit different. We use a pound, and we say import is the keyword, and then we put in quotes the name of the .h file of the classes that we want visible over in Objective-C. And the class, or the file that I want to make visible, is this UIImageView plus network. So I'm just going to type in here UIImageView plus network.h, because that's what I want visible, and that should do it. Now I have access. I've just extended the UIImageView class both on the Objective-C side of the house here as well as on the Swift side. So when I start writing the code to fetch this image, I can actually leverage this added functionality that I've written in Objective-C. So let's do that. Go back to the master view, and first of all, I'm going to assume the image is not loaded, and so I'm just going to set myself up. So this is the thumbnail, and I'm going to set myself up by simply setting. So the cell has a property called ImageView, which is going to be, if there is an image view, it's going to position it over on the left, and it's going to move the title and the detailed description over. Okay, exactly how we want it. So I can say if this thing is there and it's got an image property, which is the actual UI image, and I'm going to set that to, I dragged that Last.fm logo over into my project, and I can create UI images on any PNG or JPEG that I've added to my project simply by using a UI image initializer. So I can say UI image, and then I can say, oops, lowercase m, and then I can just pass in the parameter named and then a string, and I called this thing last_fm_logo. That was the file name, .png, but it will find it. So by default, I'm saying, hey, I've got this thing already ready, so I'm just going to set it right away to this. Then I'm going to attempt to load, and if I successfully load something, I'm going to write it back over the top of that one. So let's try to load it. The first thing we need to do to load this thing is we got to parse that image object. It's an NS dictionary coming out of my model, and figure out what URL I want to use. Well, I want to use a small one here. So the first one, you remember, had size tagged as small. So the sub-zero in that, it's actually an array, not a dictionary. The sub-zero entry in that array is the small one. So I want to get that URL out and then fetch it. So we're going to say, first of all, try to fetch that thing. So images is going to be our track object for key, and its image, and remember that was an array, an NS array technically. So this gives me that array listed under the attribute images, and then the very first image in there is the one I actually want to try to load up. So that's a URL. So I'll say if let first image equal images sub 0. Okay, and this one was a dictionary, right? There was a URL on that, so I'll say as NS dictionary, and then the URL, if we look back at the content, the URL, so it's a dictionary inside the array, and there's two attributes on that object. There's pound text, which is the URL, and then size, which is small. Well, I'm grabbing this first one. I know the size, so all I really care about is that URL, pound text. So I'm going to come in here and say if let image URL equals first image, and I can use this syntax on an NS dictionary, and this is a string. So now that I've got that, I've got a URL, now I just need to load this thing. The category that I just added gives me an extra method on UIImageView that loads this thing up and caches it so that anytime I call in the future, if it's already fetched, it won't refetch it. Okay, so when I'm scrolling through these things, if I fetch every one, you know, every time I scroll up a full screen, I'll have like 8 or 9 image fetches, and it's going to be really choppy. The scrolling is going to be really jumpy. But if I use caching, the very first time they load, you know, repeat loads are going to go a lot faster, and so when I scroll, it potentially will go a lot smoother for me. So I'm saving a lot of extra network I/O. So we can say the cell's image view in this case, and now I can call this load image. Now this was the code that got to me. This is what I got from that category. This is not on UIImageView by default. I got it through this category, and that category not only loads it, but it does all that caching with that other implementation that I added to the FTW cache that I added. So we didn't look at that code. If you read through it, you can figure out how they're actually doing it. But we're just using this at a high level here. So I can say load image from URL, and the URL I'm going to construct from that string. And the string here is image URL. And my placeholder image, well, I've already got a placeholder. It's the one I just loaded up there. So I'm going to just say this one is cell.imageview.image. And then the caching key, well, I know that my image URL is unique, right? I mean, it's the beauty of the web, right? We can give things unique universal identifiers. And so I'm simply going to use, for my caching key, the image URL. So let me just put some returns in here so it's a little bit more readable. All right, so that should be it. This matches that, this matches that, this matches that. So let's go ahead and run this. Oh no. All right, so there's some other stuff I'm going to show you tonight. And we haven't got there yet, so I haven't written this code. So I'm going to comment this out. And we'll come back to that. Okay, so there it is. And if I scroll, nice and smooth.